Okay, so chain rule is, I'm going to walk off screen as soon as I hit start. Chain rule is, I call it the blow pop rule. If you remember in the classroom behind me, there's those are Tootsie Roll Pops, but they'll work the same way. Have you noticed that those 10 or 15 wrappers of Tootsie Roll Pops?
Unevenly spaced ones, yes.
And probably wondered why Mr. Wolf is collecting Tootsie Roll Pop wrappers. This is why. Because in calculus we use the chain rule probably daily once we get into calculus. So it's super important, and the blow pop rule or the Tootsie Roll Pop is a way to remember it. We'll talk more about that in a moment. Let's just start with an easy one here. So the derivative of 7x squared is, I don't have my popsicle sticks, so what's the derivative of 7x squared? 14x. Right? Bring the 2 down, decrease the power by 1, 14x. Now, if we had 7 times 3x plus 1 squared, how would we find dy dx? Because that rule that we just used, this is more complicated than that. So I can't really use that exactly the same way. I think I would have to kind of go longhand here and multiply it all out so that I can get some individual terms and then use the power rule. So let's see here. This isn't terrible. 9x squared plus 6x plus 1. And then distribute the 7. So 63x squared plus 42x plus 7. And so that was algebra stuff there. But now we have 3 terms that are easy to take the derivative of, right? We can use the power rule on each of those 3 terms. So 126x plus 42, and the 7 would go away. So that wasn't terrible. It wasn't particularly fun having to FOIL that out, but it wasn't awful. But you look at the next one, and it's like, now consider 3x plus 1 to the 9th. Well, how could we find dy dx? I mean, I guess the only answer is we're not going to do this, but this is what you'd have to do, right? Off the page, multiply 3x plus 1 9 times. And of course, you can't really do that all at once. You'd have to FOIL and collect like terms, and FOIL and collect like terms. Or if you remembered the big triangle, the Pascal's triangle, I suppose you could get there that way. But either way, that's a lot of work. A lot of work. And even then you'd have to take the derivative. It would be very time-consuming and tedious to multiply that out. So yeah, there's a better way, and the better way is the chain rule. So here's what it looks like, and it'll be easier to use than this equation makes it look. So we want the derivative of f of g of x. Meaning we've got like a nested function thing. Like this one up here, if we rewrote that, we could say that let's see, g is our inside function. So g of x would be 3x plus 1, and f of x, the outside function, is 7x to the 9th. You remember doing that in algebra, like undoing composite functions? It was kind of tricky. But if we plugged in 3x plus 1, then we'd get what we have for y. So the chain rule is used for these nested function things, functions within functions. And layers of things is sort of where the blow pop rule comes in. When you eat a blow pop, so easy question here. I'm trying to figure out how to ask this to get what I want. When you eat a blow pop, what do you do first? Go simple here.
Take the wrapper off.
Take the wrapper off. Very nice. Good job. Should nominate you for a K award. Take the wrapper off if you want to eat a blow pop. What do you do next if you're eating a blow pop? Which part of the blow pop comes next?
You open your mouth.
The lollipop part. And then what comes after the lollipop part?
The stick.
Before you get to the stick,
Inside.
there's the gum, or if it's a Tootsie Roll, it's a Tootsie Roll stuff. But there's the outside wrapper, and then there's the candy, and then there's the gum, and then there's the stick if you really want to go all the way down, and we'll talk about that in a minute. So, but you do them one at a time. I meant to bring blow pops to pass out. I still owe you that, so I'll bring those at some point. One year I did this for calculus, passed out the Tootsie Roll Pops, and just as I was about to do that, some guy thought he'd be funny, and he stuck the whole thing in his mouth, wrapper and all, bit down on the whole thing, and started like chewing the whole thing, wrapper and all. And everyone's like, "That's disgusting. That is not how you eat a blow pop." The reason I tell you that, I'm so glad he did that. Like I should like pay somebody to do that from now on. That method is how some of you will do the chain roll. Like it's wrong, it's gross, it doesn't work, but you don't do the chain roll that way. You have to go one step at a time, and you have to work your way from the outside in. And when you're working from the outside in, like you don't mess with the inside while you're working with the, like one thing at a time. Like when you're taking the wrapper off, you're not also eating the sucker part or the gum part. Like it's one thing at a time. So what that means for this derivative is outside in, one thing at a time. The first thing we'll take the derivative of is the f. So f prime. And while we're taking the wrapper off, we're not messing with the inside, so g of x stays in there. Like we don't take the derivative of g, right? Because we do one thing at a time. We do not bite the whole blow pop at once. Now, after we take the wrapper off, then we can move to the inside and then handle the sucker part. So we'll multiply by g prime of x. And then if you want to go one further, you could take the derivative of the inside of that. Most of the time we don't write this because what's the derivative of x? 1. And so yes, you could put times 1, and that's sort of like taking it all the way down to the stick. But we usually don't write times 1. So outside in, one step at a time. The or is a form that we really don't want to worry about. It's much easier to think about it like this. Okay, this is going to become easier as we do some examples. But the main rule is, it's the blow pop rule. Outside in, one step at a time, one derivative at a time. Don't bite through the whole thing at once. Okay, example 1. If f of x is all of this cubed, f prime of x is... Okay, so what's the outermost thing in this function?
1.
Like which function is kind of on the outside? The cube thing. So let's handle the cube thing. And while we're handling the cube thing, we don't mess with the inside stuff, right? Outside in, one step at a time. So handling the cube thing means don't worry about what's on the inside. So let's use the power rule with the cube. So we'll bring the 3 down front. I'm going to write this in maybe kind of a weird order. Bring the 3 down front, reduce the power to 2. That's the power rule. Now, while we were doing that, we don't mess with the inside, so we leave that alone. X to the 4th minus 3x squared plus 9x. Then, now we've finished the outer layer. We've peeled that off. We've peeled the wrapper off. Now it's time to get to the inside stuff. So now we can multiply. That's how we chain things together. That's why it's called the chain rule, is that you're going to have this string of things, and depending on how complicated your initial function is, you could string together 3, 4, 5 things. Derivative of the inside stuff, that's just power rule on the inside. So 4x cubed minus 6x plus 9. And since we're not interested in multiplying out doing crazy algebra, we're stopping there, and that's our answer. Outside in, one step at a time. Number 2. Find the instantaneous rate of change of that thing with respect to x in terms of x. So all of that to say, find the derivative. All right, that's pretty similar to number 1, so why don't you try that one? And just do the derivative of 2x squared, or 2x to the 7th plus 5, which would be 14x to the 6th, A few of you put plus 0, but you don't need to, so either way. And then you could leave it like that. I guess you could multiply 36 and 14 and put x to the 6th out front, but you don't really need to do that. In fact, in some ways it's nicer to leave it like this because it's easier to see that there was a chain and that you did one thing at a time. All right, number 3, kind of the same thing. So inside, we're not worried about the inside. I'm looking at the outside first. 3 times 33 is 99. X cubed minus x minus 3 to the 32nd. That's kind of weird. That's the wrapper, but we got to take care of the inside stuff. So that would be 3x squared minus 1. Outside in, one step at a time. Do not eat the whole thing at once. Number 4. Find h prime of 2 if h of x equals sine of 4x. So what's the extra step on this one? Yeah, we'll plug in 2, but that's the very last thing. Let's chain rule first, and then we'll plug the 2 in at the end. Okay, this is a little bit different than the previous ones. The 2 functions I see are the sine of something and 4 times something. But which one of those is the outermost thing? Which one of those is the wrapper for the problem? The sine. So let's do the sine first. So the derivative of sine is cosine. And while we're doing that, we don't mess with the insides. Right? One layer at a time. Don't need to blow pop all at once. But then, now that we've handled the outside, we can now handle the inside. And the derivative of 4x is 4. This one does look a little weird with the 4 at the end. It's not wrong. It just might be misleading on, where does the 4 go. So it might be safer to put the 4 out front, like that. H prime of 2 then is 4 cosine of 8. I don't know what the cosine of 8 is, so I think we're just going to leave it like that. Outside in, one step at a time. Number 5, another trig example. Pretty similar to the last one. And it's got a nice value to plug in, so I think we'll get a decent answer here. All that to say, why don't you try number 5? Outermost thing is cosine. Derivative of cosine is negative sine. But let's be careful and leave 2x alone. All right, shh. But we're not done yet because we need to multiply by that 2. Okay, losing some of you. That's not wrong, but it can be cleaned up a little bit. It doesn't have to be cleaned up yet. You could just plug in the pi over 12 and see what you got. But I think it would probably be helpful to rewrite that. Plus, it's not difficult to clean it up. 3 times negative times 2 would be negative 6 sine of 2x. And then at pi over 12, negative 6 sine of 2 times pi over 12. Let's see, the sine of pi over 6 is 1/2. And then you could stop there. I just say safe stop. I mean, that's not much of a... Hopefully you know what half of negative 6 is. But this would be an okay answer. Outside in, one step at a time. Number 6 looks a little different, though. What's the outermost thing on number 6? The cosine or the 6? The 6. That 6, I mean, it's kind of misplaced when we put it there, because what it means is cosine of x all to the 6th. And then if you write it that way, it becomes obvious which one is the outermost thing. So outermost thing is 6. So that's a power rule thing. So bring the 6 down, reduce it to a 5. That's the power rule. So while we're doing the power rule, we don't mess with any other rules. We leave cosine alone, right? We take care of the blow pop one step at a time. And then the derivative of cosine is negative sine. And that would be an okay stop as long as it doesn't look like you're subtracting sine of x, right? If you write that looks like you're subtracting sine of x, and that's not what you're doing. So it would probably be wiser to pull that negative all the way out front, and maybe even write the 5 like that. That would probably be how the multiple choice answer would look. Again, this answer is okay as long as it's clear that you're multiplying by negative sign, not subtracting sign. Number 7, a second derivative. So, well, the only way to get a second derivative is to get a first derivative. What's the derivative of tangent? You got it memorized yet? Secant squared. And then a second derivative. Oh, now I see why this is in this section. Because secant squared, again, you don't have to rewrite it like that. But when you rewrite it like that, it becomes clear what the outermost function is, what the wrapper is. So the second derivative then is bring the 2 down, you get 16. Secant x to the first. And a lot of people are going to stop there, but we got to multiply by the derivative of secant. And do we know the derivative of secant?
Secant tangent.
Secant tangent. And then that's a safe stop, that's correct, but a multiple choice would clean that up a little bit. Combine those secants into secant squared x times tangent of x.
Wait, so in the first part, like a tangent x is the outside?
You could phrase it that way, but the inside is just x, so you'd be chaining it onto 1. So on the first one, it's not really a layered blow pop. It's just one thing. It's just like a candy analogy, a mint that's already unwrapped. Like it's just one thing. There's nothing to do. Just take care of the mint. Number 8. We got multiple chains going on here. I think I'm going to rewrite this. Probably most of you are fine without rewriting it. But when you rewrite it, it just becomes super clear how to go from the outside in. I should have brought more colors to do this one because I've got all kinds of chains going on here. So what's the outermost thing? The 4. So y prime is 4 times the inside stuff cubed. Right? That's the power rule. And don't mess with the inside stuff while we're handling like one rule at a time.
I think there's some headphones in here.
I did see some blue ones right here. Thank you. You're welcome. Okay, so inside stuff stays the same. So that's the sine of 3x squared. Okay, what's the next layer on our blow pop? The sine. So let's handle the sine. Derivative of sine is cosine. And while we're doing cosine, we don't mess with the inside stuff. So we leave the inside stuff the same. 3x squared. But then there's one more layer to handle. The 3x squared, which becomes times 6x. So when the things get more complicated, you can maybe see why it's called the chain rule, because this one has 3 links in the chain. And we could clean that up a little bit. I mean, there's nothing wrong with that answer. And about the only thing you could do to clean it up is 6x times 4. And then everything else would be kind of the same. Nothing much to do with it. of space. So there's your multiple choice answer, but what we wrote there is completely okay. I mean, almost preferable even, because you can see the chain and where the chain came from. Why don't you try number 9, speaking of multiple chains in a chain rule.
All of it to the 1/2.
Yeah, all of that stuff to the 1/2. And now it's I think, a fairly straightforward chain rule. Although it does have some simplifying stuff in there. So let's do this one, if only for the algebra that we'll encounter in a minute. So bring the 1/2 down front, decrease 1/2 by 1, negative 1/2. Remember, that's what gets weird if it's a 1/4 or 2/3. Some people mess that up. Leave the insides alone, because we don't eat the whole thing at once. And then we can handle the inside. That would be 8x cubed plus 3. And that's still not wrong, but a multiple choice answer is going to put that negative thing in the bottom. The 2's in the bottom. They might even replace the 1/2 with the square root. And 8x cubed plus 3. That's your multiple choice answer. Again, I feel like I should box both, because that first one is a perfectly acceptable free response answer. I mean, more than acceptable, like I would say preferred, because you haven't made any algebra mistakes because you didn't do any algebra. But on multiple choice section of the test, we're going to clean it up and make sure that you can do the algebra to get from one to the other. All right, 11, I think we can pass on. What rule is in effect on 11? There's actually a couple rules going on in number 11. There's definitely the quotient rule, and then in order to find the derivative of g, we're going to need the chain rule. Maybe we should finish this one, because this has got multiple rules kind of layered on top of each other. I've got to do the quotient rule. F prime's easy. G prime, though, to get G prime is that's going to be the chain rule. So 1/2 is the outside thing. 2x minus 2 to the negative 1/2 times the inside thing, or the derivative of the inside thing, which is just 2. And again, you can safe stop this stuff and not do any cleanup, but then your answer gets really messy. And so even though there is a safe stop available, it's probably wise to clean this up. The 2's cancel, and I would get 1 over the square root of 2x minus 2. Okay, but now I've got to kind of zoom out. And why was I doing that? What else is going on here? I will have to plug in 3, but I'm not to that point yet. Like, I got my pieces, but then overall there's a quotient rule thing going on. So I got to do the quotient rule and then plug in 3. So quotient rule is GF prime. Okay, that's the easy one. Square root of 2x minus 2 minus FG prime. So that would be x over square root of 2x minus 2 all over the bottom squared. I don't know yet. We've not done a solo quiz in a while, Jacob, and the fact that you're asking pushes me toward one end.
Okay.
Or we could be back in this room and put Jacob in the quiet room and then make it a group quiz.
Communicate with sign language.
Show each other, touching each other through the glass like a prison visit. So is this an okay answer? Yeah, no, because I haven't plugged in 3. I'm thinking if I plug in 3 now, is that going to work? Or do I want to... I want to simplify too. Like, I want to clean this up a little bit. So I think I'm going to multiply everybody by the square root of 2x minus 2. And the motivation being I will fix that denominator. But I get an added bonus of this first term, root 2x minus 2 times root 2x minus 2 is 2x minus 2. And then on the second term, the 2x minus, the root stuff goes away, and I just have minus x. And then in the bottom, that doesn't really work very well, does it? Because when I square 2x minus 2, I get 2x minus 2. And then I've still got root 2x minus 2. 2x minus x is just x. And I still haven't plugged in 3 yet. Maybe I should have plugged in 3 earlier and that would have made easier. Yes, I don't know. Because for this one, plugging in 3 gave you some nice answers. 3 minus 2 is 1. 6 minus 2 is 4. And the square root of 4 is 2. So 1/8. Is that what you got, Michael? No? I'm pretty sure it's 1/8 because I got that earlier.
Mr. Wolf, are you eating the whole thing right now?
I am not. I did that correct. So worksheet 7 is the chain rule, and again, it's the chain rule in combination with all the other rules that you're supposed to know. So we continue to build, although I guess the good thing is we're through building for now. Now we're letting the foundation set and everything kind of settle in, and you work on things. Alright, so worksheet 7 for tomorrow, although I won't take up anything until that Tuesday. And I'll take up 5 through whatever's left, 5 through 8 on Tuesday.
What worksheet's in the quiz over?
I don't have it with me, so I would say it might be up through the chain rule. It might be including what we did today.
I'm being really vague with this.
Well, it's hard to answer when I don't have it with me. Alright, so today's assignment's worksheet 7, chain rule stuff. We're done with new stuff. So I know you don't like testing on Monday, Tuesday, but that means we got 3 more days to ponder, soak in, review, and then we'll test on Monday.
Can I go to the quiet room?